Okey, semua boleh nampak skrin saya?
Boleh, Doktor.
Okay, thank you.
Boleh nampak.
Okay, I continue again. So signal to noise ratio in decibel, it is the logarithmic of the power. So what you need to do is 10 log of the power ratio, which is the signal power to noise power. Okay, Pn. Okay, so this is in term of decibel. So about the SNR, what we want to achieve is that we need as high as possible for the value of SNR. Okay, so the higher the value of SNR, the better would be the quality of the signal transmitted from the transmitter to the receiver. Okay, kita perlukan nilai SNR yang setinggi yang mungkin, paling tinggi, semaksimum yang mungkin. Okay, and last week seen about the noise factor. Okay, so in your syllabus, it is more focused on the amplifier system. Okay, where it has where the amplifier is a non-linear device which produce the harmonic distortions. Okay, so as we have learned last week, if we see the amplifier, for example, okay, so it has the input side, okay, and also there's the output side. Okay, so at the input side we have the input signal Si, and also we have the input noise. Okay, whereas the amplifier has a gain of A. Okay, and then at the output side we also have the output signal and also the output noise. Okay, so since we have two sides, input and output, that means we're gonna have two SNR, two kind of SNR. The first one is the input SNR. Okay, so we call it as the SNRI. Okay, which is equal to Si over Ni. Okay, and then we also have the SNRO at the output, which is equal to So divide over No. Okay, noise at the output. And okay, so previously we have learned that there are two scenarios where the first one is the perfect system, for the perfect system, and for the non-perfect system. For the first scenario, for the perfect system, we assume that there's no noise, there's no additional noise produced by the system. Okay, in that case, the output is equal to APSI divide with the AP and I. Okay, so the output signal power is the APSI. The gain multiplied with the input signal. The output noise is equal to the gain multiplied with the input noise. So this is for the ideal case where you see that Si over Ni, which is equal to the input SNR. So this is during the ideal case, perfect system, where the system doesn't generate internal noise. Okay, and if the signal produces internal noise, it produces additional noise ND. Therefore, the output SNR gonna be like this. Okay, so AP SI, the gain multiplied with the input signal power. Okay, so the output signal power is equal to,
Doktor,
yeah,
sorry.
yeah,
Ada yang request nak masuk
okay,
tapi
okay,
dia tak
sorry
masuk lagi.
sekejap, tak ada pun.
Oh, dah ada. Dia dah masuk dah kot.
Okay,
Alright, thank you doktor.
okay, okay. So the output signal power is equal to the gain multiplied with the input signal divide with the gain multiplied with the input noise power plus internally generated noise. Okay, so this is for the non-ideal case where the system produce additional noise, internal noise, okay, which is the NT. In this case, SNRI is not equal to the SNRO. Okay, dalam case ini, SNRO not equal to the SNRI. Okay, dalam case ini, in this case, SNRO is less than the SNRI. Okay, so sekejap, saya tengok ada pelajar baru masuk ke? Sekejap. Okay, tak ada. So saya proceed. And then we learn about noise factor parameter. Okay, we learn about the noise factor parameter. So the noise factor, okay, the noise factor F is equal to SNRI, SNR input divided with the SNR output. Okay, so and then this is a unitless parameter, tidak ada unit. So because it is just a ratio of the SNR. Remember, for this one, make sure that both SNRI and also SNRO must be written in terms of absolute value, not in terms of decibel. Okay, jangan tulis dalam sebutan decibel. Okay, when you do the process of division like this, SNR I and SNRO must be written in terms of absolute value. Okay. And then the next parameter is a noise figure. Noise figure is equal to 10 log of F. Okay, unitnya adalah decibel. Okay, the unit must be in terms of decibel. Okay, so in ideal system, okay, in the ideal system, for the SNR, for the ideal system, F equal to 0, sorry, F equal to 1. Okay, ideal system. For ideal system, the noise factor is equal to 1, as I mentioned earlier about this one. Okay, this is for the ideal system. Therefore, for the noise figure is equal to 0 dB. Okay, so what we want is that we need the noise factor to be close to 1. Okay, kita inginkan noise factor sekecil yang mungkin menuju nilai 1, and we want the noise figure to be close to the 0 dB as possible. Okay, if possible. So itulah yang terbaik. Okay, and then I will continue with the next chapter, with the next topic. What about if we have a cascaded amplifiers like this? Okay, so previously we have seen a single amplifier. Okay, we have seen a single amplifier, and then what about if we have more than one amplifier? So in your syllabus, normally we do up to 3 amplifiers cascaded together. Okay, so when we want to calculate the noise factor for the cascaded system, what we need to do is to use the Friis formula. Okay, for example, like this. So here we have the three amplifiers, example like this. So amplifier 1, we have the first gain, and also this amplifier has a noise factor NF1. And then second amplifier has a second AP2 gain, and then it has a NF2, noise figure 2, and then here is a gain, and then this is a noise factor for this amplifier. So the issue is now we want to calculate the total noise factor. Kita ingin mengira berapakah total noise factor untuk amplifier yang disambung secara cascaded. Okay, how much is the noise factor? So we need to use this formula. Okay, we need to use this formula. F total noise factor is equal to the noise factor of the first amplifier, which is this one, plus noise factor of the second amplifier minus 1 divide with the gain of the first amplifier. And then plus noise factor of the third amplifier. Okay, noise factor of the third amplifier minus 1 divide with the gains of first amplifier and second amplifier. So A1 multiplied with A2. Okay, so this one, okay, and then plus until n amplifiers, okay, n number of amplifier. So F noise factor of the n amplifier minus 1 divide with multiplication of gains of the previous amplifiers. A1 multiplied with A2 multiplied with A3 until an minus 1. Okay, and remember all of these are the unitless parameters. Okay, so okay, ini ada penerangan dia. And remember, this is a very important remarks. Okay, change unit of all noise factor F and power gains F from decibel to unitless before you insert into the Friis formula equations. So apa maksud dia? That means remember all the parameters inside the Friis equations are the unitless parameter. Okay, semua parameter di dalam Friis equation ini adalah unitless parameter. Don't put decibel inside the unit. Don't put decibel parameter inside the Friis equations. Okay, jangan letak decibel dalam equation ini. Okay, kesilapan pelajar yang lepas, the previous mistakes in the past semesters, what happened is that the students put decibel gains di dalam equations ini. Okay, that's a previous mistakes of students. Common mistakes, students put the decibel values inside the Friis equation, which is wrong. Okay, so you need to make sure that the gains, the value of F must be absolute value is a unitless parameters. Okay, jangan letak decibel di dalam persamaan ini. Tidak boleh. Okay, remember that. Because these kind of errors, these kind of mistakes happens although even though in the final exam. Okay, dalam final exam pun kesilapan seperti ini masih berlaku. So I hope that for this semester it will not happen again. Okay, make sure the gain, the value of F are in term of unitless, not in term of decibel, bukan dalam decibel. Okay, saya teruskan ya. So maybe later we're gonna see the example so that you will understand how to use the phase equations. Okay. So example 2.9, the input signal to telecommunication receiver consists of 100 microwatt of signal power and 1 microwatt of noise power. The receiver contributes an additional 80 microwatt of noise, which is the internal noise, and has a power gain of 20 dB. Compute the input SNR, the output SNR, and also the noise, the receiver noise figure. Okay. So when we can draw like this, so we can draw like this a receiver system, receiver system. Okay. So it has a input power, SI. Okay, SI is equal to 100 micro. Okay, and then it has the input noise power is 1 micro, and I is equal to 1 microwatt. Okay, and then it produce additional noise ND, which is 80 microwatt. Okay, 80 microwatt, and it has a power gain of 20 dB. Okay, so 20 dB, if you do the anti-lock, you will get 100. Okay, so the first question asks how much is the input SNR. So input SNR is equal to SI divided with NI. Okay, so SI signal power, input signal power is 100 microwatt divide with the input noise power 1 microwatt, so you get 100. Okay, and then in terms of decibel, input SNR in decibel, so 10 log 100 you will get 20 dB for the input SNR. Okay, so SNRI is equal to 20 dB. Okay, so if you see from this example, the question doesn't mention that you need to find SNR in decibel. Okay, so therefore you have options. Either you want to stop here, 100 is enough, or you want to proceed until you get decibel. Okay, why this example use a decibel for the SNR? Because normally in practical system, we normally mention SNR in term of decibel. That one is a common, biasa. Okay, tetapi dalam example ini ataupun di dalam test or final exam, if the question specifically mentioned that you need to find in decibel, therefore you need to find the value of decibel. Okay, otherwise it's up to you. You can stop until 100 is enough. Okay, soalan ini tidak spesifik meminta kamu mencari dalam sebutan decibel. And then the second question asks how much is the output SNR. So in order to find the SNRO, first you need to find the SO and then NO. How much is the output signal power and how much is the output noise power? Okay, so for me, I would prefer to find the output signal power first. Okay, first I would prefer to find the output signal power, which is gain multiplied with the input signal power. So therefore, 100 for the gain. This is anti-log of 20 dB. Okay, anti-log of the gain 20 dB, you will get 100. Multiplied with the input signal power 100 microwatt. So you get 1 times 10 power of 2 watt. Very easy. And then I will find the output noise power. So output noise power is equal to the internally generated noise plus gain multiplied with the input noise power. So 80 microwatt for the internally generated noise plus gain multiplied with the input noise. So I get 1.8 multiply with 10 power of minus 4 watt. Remember, the unit is very important. Okay, if you don't write the unit, your answer is wrong. Okay, and then I can find the SNRO, SNR output. SNR output is S out divided with the N out. So 1 times 10 power of minus 2 watt divided with 1.8 times 10 power of minus 4 watt. So you get 55.56. So this is a unitless parameter. So you don't need to write like this. Tidak perlu menulis unitless. So kalau you tulis unitless, dia agak melucukan. Sebenarnya tak perlu tulis unit. Okay, just 55.56 is enough. Okay. And then output SNR in decibel. So 10 log 55.56. So you get 17.45 decibel. Okay. Then noise figure. Okay. So if you have questions, you can always interrupt me. You can ask questions. If you don't understand, I will try to explain to you again. Okay. If you don't have questions, I will proceed.
Doktor,
Yeah.
unitless tu tak payah letak Kalau letak ada I mean, yelah sebab setengah kan dia kena jawapan dengan unit, right? So for this question tak payah letak lah. Dia tak ada markah pun sekali dengan unit tu
So what I mean is that you in the exam you don't need to put unitless. Just write 55.56 is enough. Okay, 55.56 is enough. So if you don't put unit like this, we understand that this is a unitless parameter. Itu maksud saya.
Okay.
Sebab this unitless just to show you that this has no unit. Dia tidak ada unit. Okay, so tak perlu letak ini. Okay, so itu sebab ada perbezaan. There's a difference between, for example, 10 and 10 watt. So there's a difference between these two. Okay, so this is a unitless parameter. This is a power parameter. Okay, and then
Okay, Doktor.
okay, and then the last question about noise figure. Okay, so noise figure is the logarithmic of the noise factor. So 10 log input SNR. Okay, SNRI divide with the SNRO. Okay, so 10 log 100 divide with 55.56. So you will get 2.55 dB decibel. Okay. To all students, I would suggest you to underline your final answer. Okay, saya mencadangkan kepada pelajar untuk menggariskan jawapan akhir. Okay, you can either do the underline like this, or you can sometimes the students like to do a hashtag, for example, like this. Okay, it's up to you. As long as you can show that this is your final answer. Okay, why? Because normally in the final exam, it is difficult to find the final answer. Okay, sometimes the students write above here, sometimes the students write above below here the final answer. So we need to find the final answer. Okay, it is important. So kalau you dah gariskan, so mudah untuk saya nampak you punya jawapan. Okay, sebab nanti final exam biasanya dia dah berterabur dia punya jawapan tu dah ke mana-mana So I need to know where is your final answer. Okay, that's my advice. And then example 2.10. Okay, for a non-ideal. So here it mentioned non-ideal amplifier and the following parameters. So here input signal power. This is SI. Input noise power. This is NI. Power gain. This is a power gain. Internal noise. This is the ND. Okay. Calculate the SNRI input. Okay. And then SNRO. And then F and also the NF. Remember that this question specifically mentioned that you need to find in terms of decibel. And for your information, this example has been come out in the previous semester's test. Okay, dalam test yang lepas pernah keluar soalan ini. Exactly the same. Okay, at that time is before the COVID pandemic. Okay, so we give the questions exactly like this. So many students can answer these questions, and many students cannot answer these questions. Okay, so for this semester, during the COVID, of course, this kind of question will not come out in the test because this is very easy, straightforward. Okay, so I just inform you that if you see from the question banks, dalam bank soalan yang saya berikan, uh, pernah keluar soalan seperti ini. So for all students, if you have noticed in the author, I already provides the previous semester's test and final exam questions. Ada saya masukkan dalam author, sudah lama dah. Since the beginning of the class, I already shared the question banks. Okay, you boleh belajar daripada bank soalan tersebut. Okay, so for the first question, input SNR.
Doktor,
Yeah.
yang bank soalan tu kan doktor letak kat mana?
Past semester's questions, nanti you boleh cari kat author. Kalau tak jumpa, nanti bagi tahu saya.
It's not empty.
Empty
Just tak doktor tak buka lagi kot.
Oh, tak ada
Tak
Okay.
ada.
Okay, nanti saya akan share semula.
Okay doktor.
Okay. So, input SNR is equal to input signal power divide with the input noise power. Okay, 2 times the 10 power of minus 10 divide with the input noise 2 times 10 power of minus 18. So we get 1 times 10 power of 8. So we need to find SNR in decibels. So therefore 10 log 1 multiplied with 10 power of 8. So we get 80 dB for the input SNR. And then so this is a SNRI, very easy. Okay, senang untuk cari. So the output noise, and then we need to find the output SNR, SNRO. Okay, so SNRO, I would suggest you to find, first find the output signal power because this is very easy to find. So S out, okay, output signal power is gain multiplied with the input signal power. So gain is 1 times 10 power of 6 multiplied with the input signal power 2 times 10 power of minus 10. So you get 2 times 10 power of minus 4 watt. And then find the output noise power. So output noise power is equal to internally generated noise plus the gain multiplied with the input noise power. So this is ND 6 times 10 power of minus 12 plus the gain multiplied with the input noise. So you get 8 times 10 power of minus 12 watt. So therefore, the output SNR in decibel 10 log SO S out divide with the N out. So you get 74 decibel. Okay, 74 dB. Okay. So kalau ada soalan boleh terus tanya. Okay, I proceed. Noise factor. So noise factor is equal to SNRI divide with SNRO. Okay. So here is 1 times 10 power of 8 divide with 1, 2, 3, 4, 5, 20 million, 25 million. So you get 4. Okay, so this is the noise factor. Remember, noise factor is a unitless parameter. So therefore, noise figure is equal to 10 log of noise factor. And then you get 6.02 decibel. Remember to write the unit. Okay. The unit is very important. If you just write 6.02 without a unit, your answer is wrong. Okay, jawapan kamu akan jadi salah. Okay, next. Okay, ini kalau ada soalan boleh tanya. If you have questions, if you don't understand, you can ask me. Okay, no problem. You can always interrupt my lecture session. You can ask question, no problem.
Doktor, for
Yeah,
25 ni,
yeah.
dia kat mana? Saya
Okay,
tak berapa
25.
faham.
Okay, 25 is actually from here. Okay, 74 output
Okay.
SNR. So if you convert, saya cuba sekejap. So ini
Boleh tak doktor tunjuk yang which is 74 ni convert to SNR tu?
sekejap. So this one,
Okay.
if you do the logarithmic, okay, try to do the logarithmic first. So 2 power of 10 minus 4, 2 power of 10 minus 4 divide with 8 power of minus 12. Okay, you akan dapat 25 million. Okay, so this one is okay. If I do the SNRO, okay, SNRO in unitless parameter, so this one gonna be 25. So, okay. So this is 25 million. Okay, and then if you do in term of decibel, so that means SNRO 10 log of 25 million. Okay, you will get around 74 dB. Okay, 10 log answer, so you get 73.979. So in your notes, it has been rounded up to 74 dB. Okay.
Oh. Which is kalau dia tak minta dB, kita just go on to 25 times
Yeah,
10 power of 6 lah.
yeah.
Alright,
It
okay.
depends on the questions. If the question doesn't mention in terms of decibel, you can stop here, no problem. Okay. Otherwise, if the question asks in terms of decibel, so you need to stop until decibel. Okay. But remember that in the practical case, in the practical scenario, we normally mention SNR in terms of decibel. Biasanya kita mention SNR dalam sebutan decibel. Okay, dalam practical cases memang kita buat dalam decibel. Tapi dalam case kamu, kita bergantung kepada soalan. It depends on the questions. Okay. So that's why
Okay.
that's why di sini ada 25 million. Okay. So that's why you get 4. Okay. So 10 log of 4, you get 6.02 dB. Okay. Okay, now for the 3 cascaded amplifiers, each with a noise figure of 3 and power gains of 10. Determine the total noise figure. Okay, so you are given a 3 cascaded amplifier like this. Each of these, okay, each of the amplifier has a noise figure NF, okay, and F1 and F2 and F3. Okay, 3 dB. So this one is 3 dB. Noise figure for each amplifier 1, 2, 3. Okay, yeah. And then the gain is given as A1 10 dB, A2 10 dB, A3 10 dB. Okay, so to all students, if you are given these kind of questions, I would suggest you to draw so that you can see how the system looks like. Okay, kalau kamu melukis, kamu boleh nampak macam mana gambaran soalan ini sebenarnya. Okay, so the question asks, determine the total noise figure. Find the total noise figure, NF total. Okay, in order to find the NF total, first of all, you need to find the total noise figure, total noise factor, F total. Okay, untuk mencari NF total, first you perlu cari F total. And to find the F total, you need to use the Friis equations. So in order to use the Friis equations, you need to convert the value from decibel into a unitless parameter. Remember, Friis equation tidak boleh menggunakan unit decibel. So what this example do is that see that it will convert the gain. Okay, dia akan convert gain ini. The gain is convert into a unitless parameter. So 10 dB, anti-log of 10 dB, you will get 10. Okay, boleh cuba. Okay, so 10 you need to divide with 1, and then you do the anti-log. Okay, so anti-log of 1, you get 10. Okay, and then noise factor. So if you do the anti-log of NF, you will get noise factor. Okay, so noise factor can be found by doing anti-log of the noise figure. So the given noise figure is 3 dB. Okay, noise figure yang diberikan adalah 3 decibel. So if you do the anti-log of 3, you will get 2. Okay, 1.999 something. So anti-log of 0.3, you will get 1.995. So in this example, it has been rounded up to 2. Okay, so this noise factor is equal to all noise factor is F1 is 2, F2 is 2, F3 is 3, is also 2. Okay, sama juga dengan gain, also similar with the gain. So the gain is same for all the amplifier. The gain is 10. Okay, each amplifier has gain of 10. So each amplifier also has a noise factor of 2. Okay, so now we have the A parameter and we have the F parameter. So we can find the total noise factor, F total. So F total is equal to noise factor of the first amplifier plus noise factor of the second amplifier minus 1 divide with the gain of the first amplifier plus noise factor of the third amplifier minus 1 divide with the gain of the first amplifier multiplied with the gain of the second amplifier. Okay, remember all of this must be in terms of unitless parameter. So the first noise factor is 2 plus 2 minus 1 divide with the gain of the first amplifier, which is 10, plus third noise factor minus 1 divide with gain of the first amplifier multiplied gain of the second amplifier. So you get 2.11. And then you can find the total noise figure by doing 10 log of F total, which is 10 log of 2.11. So you get 3.24 decibel. Okay, very easy.
Doktor, I have one question.
Yeah.
For noise factor tu kan,
Mhm.
yang 3/10 tu, 10 tu datang mana?
Dia gini sebab 10 log
Log, okay.
F equal to 3 dB.
Alright.
Okay, so log F is equal to 3/10. So F is anti-log of 3 over 10, which is 10 power of 3 over 10.
Okay, Doktor.
Okay. Equivalent, okay, the next topic is equivalent noise temperature, TE. Okay, so TE is the noise produced inside the system. Okay, dia adalah uh, noise temperature, TE, is the temperature inside the system. Okay, dia adalah dikatakan sebagai noise temperature yang berada di dalam sistem tersebut. Okay, so dia berbeza dengan T, okay, T parameter, which is the environmental temperature. But this one is TE, which is the internal noise temperature. Okay, so before this example show you about TE, first of all, it will show you about the environmental temperature. So environmental temperature is, remember, T equal to N divide with the KB. Okay, so ini adalah seperti N equal to KTB. Remember this? If you remember these equations, that means temperature, environmental temperature is equal to N noise power divide with the Boltzmann constant multiplied with the bandwidth. Okay. So biasanya K ini adalah dia adalah biasanya dalam huruf kecil lah biasanya. Okay. So KB, Boltzmann constant multiplied with the bandwidth. Okay. So now the value of TE and noise temperature. Okay, equivalent noise temperature. So TE is equal to environmental temperature multiplied with noise factor -1. Or if you rearrange the equations, okay, kalau kamu susun semula equations ini, you akan dapat F equal to 1 plus equivalent temperature divide with environmental temperature. Okay, so TE in term of Kelvin, T also in term of Kelvin. Okay, kedua-dua temperature ini mestilah dalam sebutan Kelvin. And in your syllabus, the environmental temperature by default is equal to 290 Kelvin, unless the question mention other value of equivalent noise temperature. Sorry, unless the question mention about other environmental temperature. Melainkan soalan menyatakan suhu persekitaran yang berbeza. Okay, but by default in your syllabus we use the environmental temperature equal to 290 Kelvin. Okay, ini by default. So these two are the main equation yang penting. Okay, so let's look at the example. Okay, determine the noise figure for an equivalent noise temperature of 75 Kelvin. So you need to find how much is the noise figure for an equivalent noise temperature. This is TE. Okay, so in order to find NF, you need to find the value of F, noise factor. So you can use F equal to 1 plus TE divide with T. So 1 plus equivalent temperature, 75 Kelvin, divide with the environmental temperature, 290 Kelvin. Suhu bilik 290 Kelvin. So you get 1.258. And then the noise figure is equal to 10 log F. So 10 log 1.258, you get approximately equal to 1 dB. Okay. So in the exam, In the test, I would suggest you to write up to 3 decimal point. Okay, dalam test dan juga exam, final exam, saya menggalakkan pelajar untuk menulis sehingga paling kurang pun 3 titik perpuluhan, up to 3 decimal points. Don't just rounded up the value. Okay, tak perlu rounded up the value. In this example, in your notes, kebanyakannya dia rounded up the value. Okay, normally it rounded up the value to make it simple, to make the student more understand about this example. Okay. So the next questions, find the equivalent noise temperature, find TE. If you are given the noise figure 6 dB. Okay, jika diberikan noise figure sebanyak 6 dB. So noise figure and F 6 dB, how much is the value of F? So we can find the value of F by doing the anti-log. Anti-log of 6 dB, you will get 4. Okay, anti-log of 6 dB, you will get 4. So therefore, the equivalent noise temperature based on the equations given, okay, TE equal to environmental temperature multiplied with noise factor minus 1. So 290 multiplied with 4 minus 1. So you get 870 Kelvin. Okay, 870 Kelvin. And then, ni kalau ada soalan boleh tanya. If you have question, you can ask. Otherwise, I will proceed to the next subtopic, which is the noise measurement. So this is about the measurement of noise in terms of voltage, RMS voltage, and you need to find how much is the average value of the noise measured at one point. Okay, so you see that here, to work with the noise communication system, it must be measured in a meaningful way. So noise is a random process and does not have a single value or an equation to describe it. So the root mean square RMS value of the noise is the most important fact. RMS value is formed by taking the square root of the average value of the individual noise voltage which have been squared. So macam mana ni? So this is the example. So assume that you take a measurement. Okay, you have some sort of like a multimeter, okay, voltmeter or multimeter. You measure the voltage, okay, of the noise voltage. So here you get 10 values. Okay, katalah you buat measurement and you get 10 values at different time. Okay, you dapat 10 bacaan pada masa yang berbeza. Okay, so here using a voltmeter, and then you get the value of 0 minus 0.3 volt, 1 volt, 0.2, 0.5, and finally 0.9. So you get 10 measurements. You have 10 measurement values of the noise voltage. So therefore, in order to find the RMS value, okay, what you need to do is, first you need to do the quadratic summation. Mula-mula kamu perlu buat quadratic summation. So all of the values, you do the quadratic summations. So the first value square, second value square, third value until the 10 value square. So you get, you plus all of this, you get 3.0325 volt square. So this is the quadratic summations. And then the average. Okay, the second step is to find the average. How much is the average? How much is the average of quadratic summation? So the average is the total summations of quadratic values divided with the total number of measurement. So here we have 10. If you have 100 values, that means you need to divide with 100. So since we have 10 values, so we need to divide with 10 because we have 10 values. Kita ada 10 bacaan dalam case ini. And then you get the answer is 0.30325 volts square. Then finally, the third step is to find the root mean square. So the root mean square is square root of average value. You get 0.55 volt. So this is the RMS noise value. Okay. Then the next example, example 2.13, noise values in millivolt as follows are measured at various times. So you get 10 values of noise taken at different time. Okay, you measure noise voltage pada masa yang berbeza, you dapat 10 bacaan. This is the example. So find the RMS noise value. So in this case, the first step is to do quadratic summation of the measured value. Okay, do the quadratic summations 10 square plus 100 square plus 35 square. So the total quadratic summation you will get 24,751 millivolt square. Okay, because the value is in terms of millivolt. The second step is to find the average. So the average value is 24,741 divided with 10 because we have 10 values. So therefore, the answer is 2,475.1 millivolt square. So this is the average of the quadratic summation. The last step is to find the RMS value. So you do the square root of average. Okay, square root of average. Okay, square root of 2475.1. You will get 49.75 millivolt. So this is the answer. Okay, the RMS value of noise voltage. Ada soalan nak tanya?
Doktor,
Yeah.
for the average value ni kan kita
Okay.
dah tambah semua which is daripada atas ni kita kuasa duakan je kan.
Okay.
So kan kita dapat nilai ni yang per 10 ni
Ini.
apa dia punya ya okey ni dah dapat kan. Yang
Okay.
per 10 ni which is kita kira yang dikuasakan dua lah kan, which is yang 10 ni 1, 2, 3, 4, 5, 6, 7,
Yeah,
8,
because
9,
we
10
have
lah
10
kan.
values. Okay, kita ada 10 value. So
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
9, 10. Yeah.
So that's why you divide with 10. If you have 100 values, that means you need to divide with 100. So untuk cari average, you kena bagikan dengan berapakah jumlah bacaan tersebut.
Kalau dalam, for the final paper, it should be dia akan bagi lebih pada 10 juga ke? Or still static? I just want to know lah. For the previous past year.
In the previous semesters, these questions has come out in the test. So previously we give only 10 values. Okay. Setakat ni belum pernah lebih 10.
Okay, Doktor.
Okay.
Okay. Thank you, Doktor.
Okay. Pelajar lain ada soalan nak tanya? Siapa lagi nak tanya? Because this is the last topic in chapter 2. Okay, ini topik yang terakhir chapter 2. Lepas ni dah habis lah. Okay, lepas ni masuk chapter 3.
Doktor nak tanya,
Okay.
untuk temperature tadi kita kena measure guna Kelvin, bukan guna degree Celsius kan?
Ya. Yang mana? Yang ini ke?
Yang tu. Yang
Okay.
TE sama dengan TF minus 1.
Okay.
Yang temperature
yang bawah ni
yang bawah tu.
Okay.
Yang T tu tu kita kena letak 290 Kelvin.
Yeah, this
Kalau
one,
katakan,
yeah,
kalau katakan I letak room temperature dalam degree, tak boleh.
tak boleh. Jawapan akan salah.
Oh.
Okay, so for example, if you are given T in term of Celsius, you need to change into Kelvin. You perlu tukar kepada Kelvin. For example, 17 degrees Celsius. Contoh saya buat contoh sekejap. So if you are given temperature in term of Kelvin, you need to change it as soon as possible. Change to the Kelvin. So this one is how to change Celsius to Kelvin. So this one 17 plus 273. Okay, so you get 290 Kelvin.
Right, thank you, Doctor.
Okay, so remember how to change into Kelvin is that temperature in terms of Kelvin. If you want to find temperature in Kelvin, that means temperature in terms of Celsius. This is degree Celsius plus 273. Okay, so you will get the value in terms of Kelvin. Okay, remember that all temperature parameter in this subject use Kelvin only. Okay, semua parameter suhu dalam syllabus kamu menggunakan Kelvin sahaja. Okay, don't use Celsius. Okay, normally we give in the question normally we give you in terms of Celsius. Okay, we want to test you, so you need to change it into Kelvin and then you do the calculations. Okay, all calculations of the temperature parameter must be in terms of Kelvin. You don't use Celsius. Okay, tidak boleh menggunakan Celsius. Okay, ada soalan lain nak tanya? So in this case, in this example, by default, the room temperature is 17 degrees Celsius, which is 290 Kelvin. Okay, so it depends on the question. If the question gives you 25 degrees Celsius of room temperature, so you need to convert into Kelvin. Okay, so in order to convert into Kelvin, you need to know about these equations. You need to plus with 273. Ini penting Macam mana nak tukar daripada Celsius kepada Kelvin, you need to add with 273. Okay, perbezaan antara Celsius dengan Kelvin sebanyak 273. Okay, ada soalan lain?
Tak ada.
Okay. Okay, so kalau tidak ada soalan, if you don't have questions, I want to proceed with chapter 3. Okay. Nota semua dah dapat nota? Dalam otak nota. Saya risau sampai sekarang kalau you kata nota tak ada, alamak. Saya risau juga.
Ada.
Because the questions yang soalan bank soalan tu nanti saya
Ya, yang bank soalan tu je tak ada.
Okay. So I put in the past year questions. Oh, kejap. So past year questions, no record. Oh, tak ada. Okay, sorry about that. Nanti saya akan letak So dalam learning material saya ada letak chapter 1 until 5, ada buku including the books, and also the POBBL instructions. Okay, PBL instructions. So okay, so later I will put here, it's supposed to be here. Okay, tak apa, nanti saya masukkan, sorry about that. Okay, so
Okay, Doktor.
okay, so saya akan I will continue with chapter 3. So if you feel tired, you can take a break for a while. Okay, but I will continue. Okay, saya akan teruskan. You can take a break for a while. You can have a drink. You can go to the toilet if you want. No problem. Okay, but for me, I will proceed with chapter 3. Okay. Okay, so chapter 3 is the main topic in your syllabus. Okay, chapter 3 ini adalah topik utama di dalam syllabus kamu. Okay, it is one of the big topic in your syllabus, which is about the analog modulations. Okay, so analog modulations inside the analog system, and this is also part of your project. Okay, some of the topics in the project is in chapter 3. Okay, for the AM, FM, PM, that one is the analog modulation schemes, and the other one is chapter 4 for the digital modulation schemes. Okay, so I need to teach you as soon as possible so that you can have more understanding about the project. Okay, so kamu perlu belajar terlebih dahulu tentang project sebelum saya ajar kamu tentang chapter 3 and 4. Okay, but you need to continue. Okay, so topics covered in chapter 3. The first part is amplitude modulations. So here you will learn about AM, amplitude modulations. So it defines the mathematical definitions, bandwidth and modulation index, about the power calculations, and then AM modulator system, AM demodulator systems. Okay, and for the first test, untuk test yang pertama sehingga power calculations. Okay, so test 1 up to power calculations. Okay, and then the second part of chapter 3 is angle modulations. So this one, part 2, repeat the first part. So it will repeat the first part. Okay, but this one for the frequency modulation and also the phase modulation, PM. Okay, dia punya subtopic, it contains the same subtopics. Okay, it contains the same subtopics, but this one for the FM and also for the PM. Okay. Okay, so as for the introductions, there are 3 properties of analog signal that can be varied by the information signal, by the input. Okay, so 3 properties of analog signal. So these refer to the carrier signal. Remember, when we do the modulation process, the property of the carrier will change in accordance with the input signal. Okay, remember the definition of modulations. Modulation is the process of changing one or more property of the analog signal. Okay, so modulation is the process of changing the property of the carrier in accordance with the variation of the input signal. Itu adalah definisi modulations. So modulations is a mixing process. Okay, you need to have at least 2 input. Sekurang-kurangnya kamu perlu ada 2 input mix together, and during the mixing process, okay, one of the signal property will change, which is the carrier. Okay, so in your syllabus, at least we have 1 input signal and 1 carrier. So it goes inside the system, okay, inside the system, and then it will do the modulation process, mixing process. But this mixing process change the property of the carrier. the carrier property will change in accordance with the variation of the input signal. So what is the property? So there are three properties, either amplitude or frequency or the phase. Okay, salah satu akan berubah dalam case ini, sama ada dia AM. So this is for AM, this is for FM, this is for the PM. Okay, so amplitude modulations is the process of changing the amplitude of the carrier in accordance with the amplitude variation of the input signal. Itu adalah definisi untuk AM. Frequency modulation is the process of changing the frequency property of the carrier in accordance with the amplitude variation of the input signal. Okay. Manakala PM, phase modulation, is the process of changing the phase property of the carrier signal in accordance with the amplitude variation of the input signal. Itu dia punya definition. Okay. So modulations also means combine. Okay. Macam saya sebutkan tadi, modulation also means combine. So what you combine? You combine the carrier signal and also the input signal. At least you need to have two input. You can have more than two input, no problem. You can have many input signal. You can have one carrier. Okay. So dalam case ini, kalau kita lukis dia punya gambar aja. Okay. So here is the input. Okay. Here is the carrier. Okay. So you can have many input signal and one carrier only, boleh. And then you can have the output. You can also have many input and many carrier. That one is a high level modulations. Okay, we don't want to go to that level yet. Okay, for your syllabus, it is enough only for one input, one carrier. Enough. Okay, very basic. Okay. If we go to the higher level modulations, we can have many inputs. So if you have many inputs, we can do the multiplexing process with one carrier, and then we can transmit. Okay, we can transmit either as AM, FM, or PM. Okay. Okay. So the carrier signal, the carrier signal has a higher frequency signal compared to the input. Okay, carrier signal adalah radio signal yang mempunyai frekuensi yang lebih tinggi daripada input signal. Okay, for example, the input is your voice, for example. So voice signal between 300 to 3000 hertz, and then the carrier for AM between 570 kilohertz until 1.7 megahertz. So it depends pada applications. For AM between 570 kilohertz until 1.7 megahertz. For FM and PM between 88 megahertz until 108 megahertz. So each system, each AM system or FM system, it has a different set of frequencies. Okay, bergantung kepada applications. Okay, amplitude modulations is the process of changing the amplitude of the carrier signal in accordance with the amplitude variation of the input signal. So dalam case ini, in this case, the amplitude of the carrier change varies with the variation of the amplitude of the input signal. Okay, so amplitude carrier berubah-ubah berkadaran dengan perubahan amplitude input signal. Okay, So maknanya dari segi amplitude, that means it change in term of up and down. Dari segi up and down, the if you see the graph, the amplitude of the carrier berubah-ubah berkadaran dengan perubahan amplitude daripada input signal tadi. Itu maksud dia. So dalam case ini, in this case, the frequency of the carrier does not change, still the same. Okay, frequency carrier, fasa carrier, the frequency and the phase of the carrier maintain the same, no change. Okay, in AM, dalam AM, only the amplitude of the carrier change in accordance with the amplitude variation of the input signal. So this is very old technology. Okay, it is a relatively inexpensive but low quality form of modulations. Okay, and it is suitable for both audio and video broadcasting. So you can transmit audio and you can also transmit video signal using the AM. Okay, so AM also used in a two-way mobile radio communications, for example, like the citizen band radio, CB radio. And then AM modulators are the non-linear device, two input and one output, modulating signal and also the carrier signal. So the modulator is the is a um, is a part in the is part of the transmitter that do the process of modulation. Dia modulator adalah sebahagian daripada transmitter yang melakukan proses modulations. So in your syllabus, you see that there are a few terms used for the input signal. Sometimes it is mentioned about input signal, sometimes it is mentioned as modulating signal. Okay, so both are the input. And carrier is another one. Okay, so terma input signal ini sometimes digunakan input signal, sometimes digunakan modulating signal. So both are the input. Okay, jangan confuse. So modulating signal, the symbol is VMT. Okay, and for the carrier signal, we use a VCT. Okay, function of time. Okay, so you see that when we write the function, we write in using a small letter. Kita menggunakan huruf kecil. So VMT for the modulating signal or the message signal. Okay, modulating signal or the input signal or the message signal, we use the parameter VMT. The carrier is VCT. Okay. There are several types of AM. Mostly common use is the AM DSBFC, double sideband full carrier. Okay, so normally we use for the most common AM is the double sideband full carrier, or simply known as the AM. So remember in your syllabus, when we mention about AM only, it is referring to the double sideband full carrier. So DSBFC is the oldest version of the AM. Okay, dia adalah generasi yang tua, yang paling lama dalam keluarga AM. Okay, AM has amplitude modulation has a few sets of family. Okay, so the oldest one is the double sideband full carrier, and then it has other siblings like the double sideband suppressed carrier, double sideband reduced carrier, single sideband, and also the vestigial sideband. So we will learn about this later. Okay. So what is the advantage of AM? It is simple, effective system, inexpensive, and it is used in the radio broadcast, TV broadcasting, aircraft, CB radio, citizen band radio, and also for the computer modem. So these are among the disadvantage. However, Okay, sorry. This is referring to the DSB FC, double sideband full carrier. So advantage ini merujuk kepada double sideband full carrier. And then the disadvantage of AM, this also referring to the double sideband full carrier. Okay, for the double sideband full carrier, among the disadvantage is that it is a waster of power. Okay, and it is because we waste a lot of power in the carrier, so therefore it is not very efficient. Okay, why it is not efficient? Why it is wasted of power? Because most of the power are in the carrier power. Ini nanti saya akan terangkan. Kenapa? Why it is said that double sideband full carrier is wasted of power? Why? Okay, ini akan diterangkan kemudian dalam topik power. Okay, but simply for now, simply to know that double sideband full carrier, the disadvantage of double sideband full carrier is a wasted of power. That's it, and it is not efficient because of that. Okay. So now this is the block diagram of the modulator. So remember that there are many components. Inside the modulator, there are many components inside the modulator. So here we just draw a simple block modulator. So di dalam sini sebenarnya ada banyak komponen electronics. Okay. So we have the input informations and we have the carrier signal. Okay, VM and also VC. So the output here is the AM signal. Okay, now is the mathematical equations. So I think you will feel excited seeing equations. Okay, mungkin kamu akan lebih rasa seronok melihat equations berbanding dengan theoretical concept. Okay, so don't worry, this is not difficult. This is very easy. Okay, this is very easy. You just need to know some of the equations used in the AM. Okay, so in AM, we use the parameter of VCT, function of VCT for the carrier, and we use VMT, function for the input signal, function for the message signal. Okay, so VCT is defined in terms of sine function, sinus function. Okay, so VCT is equal to VC sine 2 pi FCT. VMT is equal to VM sine 2 pi FMT. If you know about the sine function, remember about the sine function. If I draw here, so sine function is like this. Okay, so here the peak value is, for example, here the peak value is VC. Okay, here is a minus VC. Okay, so when we say that VC sine 2 pi FCT, that means the peak value is the VC. Okay, this capital letter is the peak value. Okay, nilai puncak dia. Okay, and then the frequency is measured by dividing 1 over time, 1 of the period of time. So for example, here is a T, so F is equal to 1 over T. So this is the basic. Okay, and then we have another parameter, what we call as the V envelope. Okay, the function of envelope is equal to VC plus VMT. So you see that here is capital VC. That means it is referring to the peak amplitude, nilai puncak. Dia bukan function. Kalau kita tulis, if we write in term of a small alphabet, it is a function. If it is a capital capital alphabet, it is a constant value. Okay, kalau dia huruf besar, dia adalah constant. So this envelope, okay, if we rewrite again, it becomes VC plus VM sine 2 pi FMT. Okay, so I will explain to you later about the envelope. Okay, because in AM we have two envelope. Okay, we have two envelope, the upper envelope and lower envelope. Okay, kita ada dua bahagian envelope. So envelope is the upper side. This the shape of this output signal. Okay, dia berbentuk seperti envelope. Nanti kita akan lihat. So this one, actually we have the so value here can be nanti kita akan lihat bahawa di sini sebenarnya boleh jadi plus minus. Dia boleh jadi ada plus and minus. So over here we can have the plus and minus actually. Okay, because we have two sides, upper side and also the lower side. Nanti kita akan lihat. And then let's look at the complete equations of AM. So the complete equation of AM is equal to V envelope, okay, V envelope multiplied with the carrier signal, sine 2 pi FCT. Okay, so when you multiply both of these, okay, you get VC sine 2 pi FCT plus VM sine 2 pi FMT sine 2 pi FCT. So you see that here, this one is sine and sine. Okay, sine and sine. So according to trigonometry identity, berdasarkan trigonometry identity, sine A sine B is equal to cos A minus B over 2 minus cos A plus B divided with 2. Okay, berdasarkan trigonometry identity, we can rearrange the equations for sine A sine B into a cosine function. Okay, so therefore, we can rewrite the equations to be like this. VC sine 2 pi FCT plus, ni yang tadi So this one, after doing the trigonometry identity, we get two sides. Okay, so Vm over 2 cos Fc minus Fm. So this is A minus B. So this is A minus B, and this is A plus B. Okay. So Vm over 2 cos 2 pi Fc minus Fm t minus Vm over 2 cos 2 pi Fc plus Fm t. Okay. So if you see from here, this is a lower side frequency, LSB, and this is the upper side frequency, USB. Okay, upper sideband and also the lower sideband. Okay, LSB means lower sideband, USB means upper sideband. Okay, so modulation does not contain frequency modulations. Modulated wave does not contain frequency modulation. So the effect of modulation is to translate modulating signal in the frequency domain so that it is reflected symmetrically about the carrier frequency. So ini adalah proses modulation yang berlaku. Okay. So what happened is that it looks like this. So the first one is the carrier signal. You see that carrier signal, the ripple is very close one another. So dia punya bentuk gelombang itu rapat-rapat. So if the wave is if the ripple is very close to each other, that means it is a higher frequency compared to this one. This one is the input signal. Okay, input signal which is also sine function. So this is a VCT, and here is a VMT. Okay, so you see that the ripple is far from each other. So in term of frequency it is lower. So kalau gelombang itu dia jarak-jarak, maknanya dia punya frequency lebih rendah berbanding dengan gelombang yang mempunyai gelombang yang rapat-rapat. So kalau rapat-rapat dia punya frequency dia lebih tinggi berbanding dengan jarak-jarak. Okay. So this is the AM signal. The last one is the AM signal. Okay. So this is for the double sideband full carrier. Okay, so you see that here, if you see from the carrier has a peak value of 10. VC is equal to 10 volt. Here the peak value is 5. VM is equal to 5 volt. Okay, and for the AM, you see that here the peak value is VC plus VM, which is 15 volt. Okay, nilai puncaknya adalah VC plus VM. Okay, so you see that this is for the double sideband full carrier DSB FC. Okay, so you see during this modulation process, the amplitude of the carrier change in accordance with the amplitude variation of the input signal. So at the beginning, the amplitude of the carrier looks like this, almost symmetry. Okay, like this. Pada awalnya, amplitude carrier ini bersifat seragam. And then after the modulation process, the amplitude of the carrier change in accordance with the amplitude variation of the input signal. Okay, so perubahan amplitude input signal ini telah mengubah amplitude property of the carrier. So you see that here, the amplitude of the carrier change. Okay, the up and down change regularly according to the input. Okay, dia bergantung kepada input. And for your information, this red color, okay, the line, this red color line is what we call as the envelope. Okay, this is the imaginary line. Okay, dia tidak wujud sebenarnya. It doesn't exist actually. It is an imaginary line. Okay, so this is the upper envelope and this is the lower envelope. So this red color is just the imaginary line. Dia adalah garisan imaginary yang kita lukiskan untuk menunjukkan bahawa adanya envelope di atas itu. Okay, so this is the red color is the envelope. So actually the signal is inside this one. This is the actual signal. The AM signal looks as if contains inside the envelope. This AM signal ini seolah-olah berada dalam envelope AM tersebut. Itu terma envelope bermakna dia sampul seolah-olah macam dia sampul signal tersebut seolah-olah. Okay, so the AM signal contains inside the envelope, this envelope. So di dalam sini yang color, the blue color is the AM signal. Okay, so this is the AM signal in time domain. Okay, normally we call it as waveform. Okay, kita panggil sebagai waveform. So when you ask to draw the AM waveform, you need to draw like this. Okay, when you ask to draw the frequency spectrum, that means it is in terms of frequency domain like this. Okay, kalau diminta melukis dalam frequency domain, what you can do is that you can do based on these equations. Okay, so these equations you can write in terms of frequency domain, which we have 3 components. Okay, so F, so we have this one, lower sideband, carrier, and also the upper sideband. Okay, so this is FC minus FM. This is FC plus FM. This is the carrier at the middle. Okay, and regarding the amplitude, this is VM over 2. This is Vm/2. And the amplitude of the carrier is Vc. Ni saya ambil daripada equations. Remember, when you want to draw the frequency spectrum, first of all, you need to define the equation. From the equation, then you can draw the frequency spectrum. Okay, so you see that I take from here, this is a Fc for the carrier, okay, for the carrier frequency, and the value, the amplitude is Vc. You see from here, from these equations, Fc minus Fm, it is for the lower sideband. The value is Vm/2, the amplitude. This is, on the right side, is the upper side frequency, upper sideband, okay, at the frequency of Fc plus Fm, and the amplitude is Vm/2. So I draw Vm/2. Okay, only from this equation I can draw the frequency spectrum. Otherwise, I don't know how the frequency spectrum looks like. Okay, jangan melompat, jangan terus come out with the frequency spectrum. You need to know the equation first. Okay. So if you see from the spectrum, frequency spectrum for the double sideband full carrier. So double sideband full carrier, you see double sideband. So that means we have two sideband, lower and upper sideband. Okay. So this is the USB. Sorry, this is the LSB, and this is the USB, upper sideband. Okay. And LSB lower sideband is located at Fc minus Fm, and then the carrier, and then the upper sideband is located at Fc plus Fm. So this is a F axis. Okay, so yang atas ini boleh jadi dalam sebutan voltage or power, depends. So now we want to calculate the bandwidth. So the bandwidth is, you see that here the distance is Fm. Here the distance is Fm. Jaraknya adalah Fm dan Fm. Okay, so that's why the bandwidth is 2Fm. Okay, kalau you nak kira secara mathematicsnya, dia adalah bersamaan dengan upper sideband Fc plus Fm, okay, minus the lower frequency Fc minus Fm. Okay, so it is equal to 2 Fm. Okay, jarak dia punya bandwidthnya adalah 2 Fm. So bandwidth for the double sideband full carrier is equal to 2 times the input message frequency. Okay, dalam sebutan hertz, in term of hertz. Like this. Okay, so 2 Fm. So you see that several baseband signal may be transmitted simultaneously on different carrier frequencies, multiplexing, provided the sideband do not overlap. So that means we can transmit many input signal together, okay, by the carrier, using the carrier signal. Kita boleh melaksanakan, we can do the multiplexing process. We combine many input and then we transmit using AM. We can do that, no problem. Okay, so the information in the baseband information signal is duplicated in the LSB and the USB, and the carrier conveys no information. Apa maksud dia? So you see that if I draw this one, okay, in the frequency domain, okay, in the frequency domain, okay, okay, so this is the LSB, this is the USB, this is the carrier. Okay, so information only contains inside the lower sideband. Okay, information terkandung dalam. So the information information is inside this lower sideband and also inside this upper sideband. Okay, so information contains inside here. Okay, and it is the same information. Upper sideband, upper sideband carries the same information with the lower sideband. So it is like duplicated. Okay, so information terkandung di dalam lower sideband dan juga di dalam upper sideband. Kedua-dua information ini adalah benda yang sama. So it looks like you transmit more than once. Okay, as if you transmit more than once. Seolah-olah macam you transmit lebih daripada sekali. And then the carrier doesn't convey any information. Dia tidak membawa sebarang info. Okay, di dalamnya tidak ada info. It's like empty nothing macam tin kosong nothing. Okay, so for the double sideband full carrier, you see that we transmit signal twice actually. Actually we transmit as if we transmit twice the signal. Okay, signal pada upper sideband and lower sideband are the same. Okay, so that's why nanti kita akan lihat bahawa we have wasted in terms of power because we transmit more than twice actually. Okay, this double sideband full carrier, we send the information duplicated as if we send twice. Seolah-olah macam kita hantar dua kali. Seolah-olah. Okay, so that's why nanti kita akan lihat bahawa double sideband full carrier ini wasted in term of power because of this. Okay, so about this, I will explain more in term of power so that you can have more understanding. Okay, modulation index. Modulation index is the ratio of message signal, okay, peak amplitude of the message signal divide with the peak amplitude of the carrier signal. Remember, this is the peak amplitude. Okay, what is peak amplitude? This one. So this is the peak amplitude. Okay, peak amplitude daripada signal. So for example, VMT is equal to VM sine 2 pi FMT. So VCT is equal to VC sine 2 pi FCT. So in this equation, in the modulation index, we use the peak amplitude. Okay? We use the peak amplitude, which is this one, peak amplitude. Okay. Remember, peak amplitude of the input divide with the peak amplitude of the carrier. So this is very important. Okay, and we can also write in terms of percentage, Vm over Vc multiplied with 100%. Okay, so I want to show you about the previous mistakes, common mistakes by the student. What happened? Previously, many students wrote like this. The first error is like this. The students write like this, M equal to Vc over Vm. This is wrong. The second mistake is that some students wrote like this, VMT divide with VCT. This is also wrong. Okay. Remember, what you need to write is the peak amplitude. It's a constant value. Okay. So this is you can write in terms of percent. Okay. And this modulation index can can show us three scenarios. Okay, modulation index ini boleh membawa maksud kepada tiga senario yang utama. Okay, there are three main scenarios according to the based on the modulation index values. There are three extreme cases. Okay, the first one is the under-modulated. Second one is the ideal AM. Third one is the over-modulated. So all of these three extreme cases is based on the modulation index parameter. So if the modulation index less than 1, we call it as under-modulated. For the ideal case, M equal to 1. So in this case, Vm is equal to Vc. For the over-modulated, M more than 1. That means Vm more than Vc. Okay. So how does these scenarios looks like? Macam mana senario ini? Macam mana bentuk senario ini? Okay. So you see that for your informations, these types of modulation index, types of modulations is also a favorite question in the test and the final exam in the previous semesters. Okay, ini juga salah satu daripada favorite question yang sering ditanya dalam test dan juga final exam, where the question asks explain the three different types of amplitude modulations, which is based on the modulation index. So we have the under-modulated AM, ideal AM, and also the over-modulated AM. Okay, so these are the things. So for the under-modulations when the modulation index less than 1. That means Vm, the peak amplitude of the input message, less than peak amplitude of the carrier. So in this case, the signal strength obtained at the receiver is not exactly the same as the signal strength at the transmitter. Okay, so when you transmit at the longer distance, okay, and you transmit from the transmitter to the receiver, okay, so the signal strength from the transmitter is very big, okay, compared to the signal strength you receive at the receiver, okay, very small. Sorry. Okay. You receive a small amplitude of signal in the receiver. Why? Because this is due to the attenuation process. When the signal has traveled at longer distance, it will attenuates, and at the end, when it arrives at the receiver, the amplitude becomes smaller. Okay, so if we want the signal strength to be more powerful, we need to transmit at a very high power of using a higher voltage, so that the signal at the receiver becomes bigger. Okay, kalau kita nak signal itu kuat, kita perlu amplify the signal so that the receiver can receive a high amplitude signal. Okay. So there is no distortion. Although it is a low amplitude signal, reduced strength, but there is no distortions. This is okay. Okay, this is a good modulation types. Okay, ini adalah jenis modulation yang baik. Okay, yang okay. And then during the ideal case, ideal AM modulations, so VM, peak amplitude of the input message equal to the peak amplitude of the carrier. So this will produce the greatest output at the receiver without distortion. Okay, tanpa ada distortion. Maximum info signal amplitude is transmitted from the transmitter to the receiver. More info signal power is transmitted, okay, because we are using a high power. So these produce a stronger, more intelligible signal. This is hard to achieve, especially when the modulating signal amplitude varies randomly over a wide range. Only the peak of the signal will produce 100% modulation. So this is a 100% modulation index. Okay. So what's the difference? The difference is you can see from the waveform is over here. Okay. So the difference in terms of the waveform you can see from here. Okay. Compared to the previous one. Okay. Perbezaannya di sini Okay, at this part. Okay. And then the third types of AM modulations is when the modulation index more than 1. Okay, more than 100%. So that means the peak amplitude of the input message is bigger than the peak amplitude of the carrier. So this will cause the distortions. It will give this the negative peaks of the waveform will be clipped off. The original shape of the signal will be destroyed. So what does it means by clip off? This one, it is a clip off. The peaks is clip off. Dia bersilang seperti ini Clip off. So normally in the questions we ask the students to draw, okay, for ideal case, for under modulated AM modulations, for over modulated AM modulations. So you need to have explanations and also the picture. Okay, what we want to see is that student understand that for the over modulation the signal will be distorted like this, the peak will be clipped off, and then during the ideal case it is like this, and during the under modulation the waveform looks like this. Okay, so you don't need to draw very beautiful. You just need to make sure that the shape of the waveform is there. Okay, kamu tak perlu lukis terlalu cantik Kamu just cukup hanya sekadar menunjukkan bentuknya. Okay, bentuknya sudah betul, makna you dapat markah yang tepat markah yang betul. Okay. So what I mean is that you don't need to waste your time draw very beautiful graph like this. So what we need to know is you understand about the waveform. Okay. Okay, so this is how we can find the modulation index. Okay, so here you see that modulation index can also be calculated using the maximum output voltage. Okay, using the maximum output voltage. For example, previously we see this one. Previously kita dah lihat yang ini we have seen this Vm over Vc. But we can also write in terms of Vmax and also Vmin. Okay, so Vmax, what is Vmax? What is Vmin? So if we look from this picture, this is the AM signal. Ini adalah AM signal, double sideband full carrier. And you see that this is the waveform in terms of time domain. Okay, so at the middle here is the x-axis in terms of time domain. And here is in the y-axis is in terms of voltage. Okay, so you see that double sideband full carrier signal, the AM signal looks like duplicated up and down, upper side and down side. Okay, seolah-olah dia macam duplicate, okay, as if there's a mirror over here. Okay, seolah-olah macam ada cermin di situ yang mana dia ada bahagian negative side. There's a positive side and there's also the negative side. Okay, so Vmax over here. Okay, so this is Vmax. Okay, and here is Vmin. Okay, puncak yang rendah ini adalah Vmin. Okay, and here is the, di bawah sini adalah minus Vmax, and over here is minus Vmin. Okay, and you see that Vc, okay, Vc is from the x-axis until the middle of here. Okay, before we see the Vc, sebelum kita lihat Vc, di sini adalah start, this one. Okay, so this is according to the VM message, and the center would be here. Okay, so here is the VM, here is the VM also. Okay, and then Vc is from the x-axis up to the middle here, which is the Vc, and the upper side here is the VM. In short, you can say that Vmax is equal to Vc plus Vm. Dengan kata lain, kita boleh katakan bahawa Vmax is equal to Vc plus Vm. Vmin, okay, Vmin is equal to Vc, okay, because Vmin is here, Vmin is this one, very small, this one Vmin, okay, so this one is Vmin. So Vmin is equal to Vc minus Vm. Okay, so when we find the modulation index, M is equal to Vc divided with Vm, which is equal to Vc, sorry, saya buat terbalik nampak so I've made a mistake over here. You see, so M is equal to Vm over Vc. That means this one is Vm. So this is so how we want to relate this one? Vm, Vc, and also the Vmax. Okay. So here, if you see, Vm is equal to Vmax minus Vmin divided with 2. Vc is equal to Vmax plus Vmin over 2. Okay, so when we divide this one, Vm over Vc, so that means Vmax minus Vmin divide with 2 divide with Vmax plus Vmin divide with 2. So therefore you get M equal to Vmax minus Vmin divide with Vmax plus Vmin. Okay. You can also write in terms of peak to peak. Okay, so if it is a peak to peak amplitude, okay, daripada peak positive to peak negative, previously we only consider half. Okay, in this case, dalam case ini kita cuma consider separuh bahagian. But we can also consider the whole sections, okay, positive and negative. Okay, in that case, you can write Vmax peak to peak minus Vmin peak to peak. Okay, divide over Vmax peak to peak plus Vmin peak to peak. Okay, so maybe this is maybe you don't understand about this. So maybe I can redraw in a different place so that you boleh faham. So saya akan cuba lukis di tempat lain. Okay, saya akan cuba lukis di sini. Okay, so assuming that, okay, let's draw like this. Assuming that VC is equal to 10 volt. Okay, assuming that VM is equal to 8 volt, for example. Contoh, so how you want to draw the AM signal? So I will teach you how to draw the AM signal. So when you draw the AM signal, first of all, you need to draw the axis like this, okay? And then I would suggest you to draw the small axis over here. So this is VC plus VM. So VC plus VM is, for example, over here. So this is okay. Yeah. So over here is VC plus VM. Okay, over here, for example, this is a minus VC minus. So what I do is that like this. Okay, so here is. Okay, saya padam balik. Okay, I draw the imaginary line. Okay, so this is the time axis. This is the voltage axis. Okay, so and then I draw this one. So I delete this one first. Okay, so when I draw like this, okay, so from here you can see that this is VM over VC, okay, which is a Vmax. Okay, Vmax. Okay, and then over here is the Vmin, which is equal to VC minus VM. VC sini VC minus VM. And then here is minus Vmax, okay, and then here is minus Vmin. Okay. So Vmax over here, Vmax, this Vmax is equal to Vm plus Vc. Pelajar-pelajar tolong mute So this one is 10. So 8 plus 10. So this is equal to 18 volt. Okay. And Vmin here, okay, this Vmin is equal to, so over here, this, so this one, Vmin is equal to Vc minus Vm. So this is equal to 10 minus with 8. So you get 2 volt. Okay. So here is minus Vmin. If minus Vmin, that means here is minus 2. Minus Vmax means minus 18 volt. So when you want to find the modulation index, what you can do is that M is equal to Vmax minus Vmin divide with Vmax plus Vmin. Okay, so Vmax is 18, okay, minus 2 for Vmin, and then Vmax 18 plus 2. Okay, so you can try to calculate this one. Okay, so this is 16 divide with 20, so you get 0.8, or this is also equal to 80%. Okay, so this is similar if you calculate, okay, sama juga, okay, it is also similar if you calculate in term of Vm over Vc. Yeah. Sama juga kalau you buat M equal to Vm Vm over Vc. So Vm over Vc. Okay, you akan dapat jawapan yang sama lah. Okay, you will get the same answer. If you do Vm over Vc, so that means 8 divide with 10, so you get a 0.8. Sorry. You get a 0.8, which is also 80%. Sama. Okay. So you need to understand about this Vmax and Vmin. This is very important because this has been come out in the test and also in the final exam. You will be given a waveform and you need to find the value of Vm, you need to find the value of modulation index, and so on, dan seterusnya. Okay, so you need to understand about this. I would suggest you to practice so that you know how to draw the waveform. Okay, so kamu perlu practice supaya kamu boleh lukis dengan laju. So I go back to the slides. Okay, I go back to the slides. So students, if you have questions, if you don't understand, you can always interrupt me. You can ask questions. Okay, I will try my best to explain to you. Okay. So based on the equations, Vc sine 2 pi fct plus Vm over 2 cos 2 pi fc minus fm. So this is the LSB. Okay, so this is the LSB, this is the USB. Okay, and if we change the value, if we change the value of Vm over Vc, sorry, if we change to, kalau kita gantikan Vm, if we change the Vm into MVc, okay, we can rewrite the equations to become Vc sine 2 pi fct plus MVc over 2 cos 2 pi fc minus fm plus MVc over 2 cos 2 pi fc plus fm. So why do we need to write like this? Okay, sometimes the value of Vm is not given. Ada kalanya nilai Vm tidak diberikan. So therefore you can use these equations, no problem. You just need to change Vm into MVc. Okay, so that means the frequency spectrum, okay, spectrum frequency will looks like this. Okay, sorry. The frequency spectrum will look like this. So this is a Vc, this is MVc over 2, this is MVc over 2. Okay, and this is a lower sideband Fc minus Fm. This is Fc, and then this is the upper sideband Fc plus Fm. Okay, Fc plus Fm. Example. So a carrier signal with a peak voltage of 2 volt. So this is Vc, is amplitude modulated with another signal, 10 kilohertz of sine wave. So this is another signal. This is not the carrier, therefore this is the modulating signal or the input signal. So you are given the input signal frequency Fm. The modulation voltage has an effective value of this one, 750. Okay, 750 millivolt. So this is the Vm RMS. Find the following percentage in modulation. So when you want to write the percentage in terms of modulation index, you need to find the peak value. Okay? So in order to find the peak value, Vm peak is equal to Vm RMS. You need to multiply it with square root of 2. Okay? So 750 milli darabkan dengan punca 2 square root of 2, so you get 1.06. Okay, so 1.06 divide with 2, so it is around 53.03. So first of all, you need to find this one. You need to multiply with square root of 2. Okay, so 750 milli multiplied with square root of 2, and then you divide with 2 volt. Okay, you will get a 0.5303, or it is equal to the 53.03%. Find the instantaneous voltage of the positive and negative envelope when the 10 kilohertz of the input sine wave has completed 68 microsecond of cycle. How to find that one? Okay, so if you see from the graph, okay, so at 6, and this is time domain, this is the voltage, so this is for the voltage. So at 68, okay, that means we have the Okay, so let's say 68 over here, 68 microsecond. Okay, that means at 68 microsecond, we're gonna have a positive and negative value. Okay, we're gonna have two values. Okay, we're gonna have two values, the upper side envelope and also the lower side, because when we cut a time domain, okay, when we cut the time domain, so that means dia akan ada dua value, upper side and also the lower side. Okay, so that means we need to use the envelope equations. Okay, so envelope equations, you see that here Vc plus Vm sine 2 pi fmt. Actually here you need to write plus and minus. Okay, because we have upper and lower. Okay, so Vc plus Vm sine 2 pi fmt. So you need to um, put inside the values. Okay, so this is 2 is Vc, and then in bracket 1 plus m. This one is based on this one, because when we rearrange the equation, we put outside the Vc. Okay, so we can do Vc in bracket 1 plus m modulation index sine 2 pi fmt. Why? Because we already get the modulation index over here, so why not we use it in our calculations. Okay, so 1 plus m sine 2 pi fm 10 kilohertz multiplied with the time 68 microsecond. Okay, so you will get the value of 1.04, and then you just need to put plus and minus. Okay, pastikan kamu dapat 1.04. Okay, so here when you do the sign, you need to use a radians. Okay, pastikan kamu guna radians. Dalam kamu punya calculator, you need to put it as a radian. Okay, so 2 pi times 10k times 68 micro, and then sign of answer, okay, plus 1 multiplied with 2, so we get sorry, 2 pi darabkan dengan 10k darabkan dengan 68 micro. Okay, and then sign answer multiplied with 0.5303 plus 1 multiplied with 2, so you get 1.04. But remember, you need to do plus and minus. Why? Because we have the upper side envelope and we have the lower side envelope. So that's why we need to put plus and minus. Okay, because this is a double sideband full carrier. It has a positive side and it has the negative side. Okay. The next one is illustrate the resulting AM waveform. So you can draw the waveform. Okay, you can draw the waveform, but remember, I need to know where is the Vmax. You need to label the Vmax and also the Vmin. Okay, how much is the Vmax? How much is the Vmin? Sorry, here is minus Vmax. Here, sorry, here is minus Vmin. Okay, so how much is Vmax? How much is Vmin? So Vmax is Vm plus Vc. Vmin is equal to Vc minus, sorry, So Vmax is equal to Vc plus Vm, and Vmin is equal to Vc minus Vm. So you can calculate. So here is a Vc is equal to 2 volt. Okay, and then Vm is equal to how much this one? Yeah. Okay, so Vc is equal to 2 volt. Vm is equal to 750 milli multiplied with square root of 2. Kita kena cari, we need to find the peak amplitude. So Vm is equal to 1.06. Okay, 1.06. So therefore Vmax is equal to 3.06. Okay, for the Vmax. And for the Vmin is 2 minus
Doktor.
yeah,
How to get 1.06? Which is I
7
calculate dapat kosong point lebih. Tu yang tanya tu.
750 milli multiplied with square root of 2.
Wait. Multiply of square root.
Of 2. Because you are given 750 in millivolt
Oh,
in
okay.
RMS, so you need to find the peak value. So when we calculate the peak value, so you need to multiply it with square root of 2. So you get the Vc, you get the Vm. So Vc is 2 volt, Vm is 1.06. So therefore the Vmax is 3.06. The Vmin is equal to 2 minus 1.06, around 0.94. Okay, for the Vmin. Okay. So here above here is supposed to be 3.06. The highest peak is 3.06. The lowest peak is minus 3.06. Okay. And the Vmin is supposed to be 0.94. So positive 0.94 and also negative 0.94 for the negative Vmin. Okay. So this picture, the value is wrong. Okay, I think that this is based on the RMS value. So when we do the in term of peak value, it is supposed to be 3.06 for the Vmax. Vmin is 0.94, and then for the negative side, negative 3.06 and negative 0.94. Okay, and when you draw, make sure you write the x-axis. This is time domain, and the other one y-axis is in term of voltage. Okay, voltage versus time. Okay, so next week I will explain to you about power. So that's all for today. Okay, hanya itu sahaja sehingga hari ini. Minggu depan saya akan ajar tentang power. So I think maybe next week we already cover the topics for test 1. And I've been told that this week we're gonna have a quiz, short quiz, using a Google form. Okay, pada hari Kamis. Okay, on Thursday, if you see my message in the WhatsApp group, okay, we're gonna have quiz 1 on the 15 April from 5 p.m. until 5:45 p.m. This is only for chapter 1. Okay, so we're gonna give you a Google form quiz, objective quiz, very easy. So I think between this 5 to 5:15 to 5:45, around half an hour, maybe 5 question or 10 question objective. That's it. Very simple. So you can answer and then you can submit. Okay. Cuma kalau kamu ada test lain, kamu kena perlu beritahu saya segera. If you have other tests which is clash with the ECS test time, you need to inform me as soon as possible. Okay, setakat ni kalau ada clash, boleh bagi tahu saya, no problem. Nanti kita akan fikirkan waktu lain, ataupun maybe you kena ambil repeat test, maybe. Okay. So now is for the attendance. So I will take the attendance, and for those who already scan the QR code, you can log out and then you can go to another class. Siapa yang dah ambil attendance boleh pergi ke kelas lain. Okay, boleh scan kehadiran. So siapa dah scan boleh stop, boleh keluar dan pergi ke kelas lain. And then we have a few minutes. You boleh tanya saya soalan. Any question you want to ask, you can ask me questions. No problem.
Doktor, saya ada soalan.
Okay.
Untuk yang tadi V envelope tu, dia kan guna formula VC tambah VM sin 2 pi FMT kan?
Okay.
Bila dia factor out, kenapa dia punya sepatutnya dia punya factor out tu kalau darab dalam, dia punya dekat belakang tu bukan sepatutnya dia VC ke?
Persamaan AM. You mean the AM equation?
V envelope punya equation, bila dia factor out, sepatutnya dia bukan VC tambah VM ke? Kenapa dia punya VC tu suddenly tu tukar jadi VM
Okay, nanti saya tengok balik sekejap So siapa ambil attendance, siapa dah?
Doktor, saya tak
Doktor.
boleh nak scan.
Boleh ni tak manual?
Okay. Siapa nama?
Siti Sarah Abdullah.
Okay. Siti Sarah, lepas tu nama saya Nur Salimah. 34 ya.
Okay.
Saya
Thank you, Doktor.
Terima kasih doktor.
Siapa lagi boleh scan tak?
Doktor, saya 30.
Tak boleh scan
Sebab saya guna phone.
Doktor, saya pun tak boleh scan.
Siapa nama?
Doktor,
Nama? Your name?
41.
41. Your name is Sharma.
Yep.
Okay.
Dr. Muhammad Osman Adam.
Osman Aden.
Yep.
Which number? Okay, Osman Aden. Siapa lagi?
Muhammad Faris Haikal.
Faris Haikal.
17.
Okay. Next. Semua sudah Ada lagi?
Nur Sarah Farahani.
Siapa?
Oh, dah. Okay. Nur Sarah Farahani dah.
Okay. Yang lain dah
Doktor, nama saya dari sini.
Nombor berapa?
38.
38. Okay, Nurshida. Okay. Dah.
Ada lagi Doktor, Gosnia. Nombor 8.
Okay.
Terima kasih, Doktor.
Ada lagi? Siapa lagi belum? Nanti yang tanya soalan tu nanti sekejap nanti saya tunjukkan ya sekejap. Semua dah Attendance semua dah ambil dah? Ada lagi yang belum ambil attendance? So 7 absent 7 students absent today. So calling. Siapa lagi belum ambil attendance? Any more attendance? Any more attendance? No Semua dah
Tak ada Doktor, dah.
Okay, so okay, pelajar yang bertanya tadi masih ada lagi tak?
Ada dekat sini.
Okay. Sorry, saya nak terang. Okay, which one?
Yang nombor B tu. Kalau dekat B, bila dia factor out yang belakang dekat M sana, bukan sepatutnya dia punya nilai tu VC ke kalau darab masuk?
Okay, so dia sepatutnya gini kan, dia sepatutnya
Ke value VC sama dengan VM?
no. Yeah. So this is supposed to be VC plus so VC plus VM. So bila kita tulis so bila you factor out because VM, sorry. So VM is equal to MVC. Right.
Yeah.
VM is equal to MVC. So that means this one is you factor out VC 1 plus this one is VM. So VM is equal to MVC because you already put outside the VC.
Oh, so kita just letak M sajalah.
M saja, ya. M sin 2 pi F MT.
Right.
Because this one over here is MVC.
Oh, MVC.
Sebab you dah keluarkan VC, so VC outside, so that one is supposed to be MVC lah.
Then untuk bawah dapatkan dia punya value untuk 1.06 tu, bukan sepatutnya dia jadi 1.04.
1.04 So 750 milli darabkan dengan square root of 2 1.06 kan? Kenapa 1.04?
I tak faham macam mana nak dapat untuk yang nilai 1.06.
Oh, 1.06 sebab tadi you diberikan nilai VM dalam sebutan RMS. Which is this one. 750 milli. That one is in term of RMS. But when you calculate the modulation index, you need to use the peak amplitude. So in order to convert from RMS into peak amplitude, you need to multiply it with square root of 2. So VRMS, VRMS, you need to multiply it with square root of 2 so that you get V peak, VM peak, VM peak.
So maksud dekat sini yang 1.06 tu adalah peak value lah untuk
peak value for the VM. Peak value for the VM. And this is a peak value for the VC. Okay, if you see from the question, dia berikan ini peak this is peak for the carrier and you are given the effective value which is the RMS value for the VM. You are given the VM RMS. But in the calculation, dalam calculation kita perlu gunakan peak amplitude. So if you draw the picture, actually the picture like this kalau dia RMS, if the value is RMS is slightly less than the peak. Okay, the peak is over here and the RMS is over here, VRMS. So when you want to find the peak value, you need to multiply it with square root of 2. Okay, so V peak is equal to VRMS multiplied with square root of 2. So therefore you get the peak value.
Right. Thank you, Doctor.
Okay. Itu saja. Okay, so that's all for today. So saya rasa ramai yang dah keluar Okay. So thank you everybody. So see you again next week.
Doctor.
Okay, jumpa
Thank you,
lagi
Dok.
minggu depan
Thank you, Doktor.
Okay,
Selamat
bye-bye.
doktor.